going to start recording this. There's an example of a IP4 address. Notice the four different bits. There are 8 bits in each of those 4 components of the IP address. So a 32-bit address that we use, and it has meanings. Do you remember this from before? Classful addressing and classless addressing. Oh my gosh. So this is all old stuff. Class A, Class B, Class C, Class C. Yeah, okay. And the use of Class A is reserved for certain things. Class B, Class C we use a lot for our own subnetting. Yeah, and so Class A is going to be, it says there through to 10255. That's not just, yeah. This is our, private addresses for Class A. Do you remember all this? Yeah. Depending on the, you can have a different number of IP addresses for your Class A, B, and C. Class A, you've got a limited number of IP addresses because you only are using the first octet. Class C, we're using the 3 octets there, and so you can have a lot more IP addresses. Students are telling me here that this is all familiar, so I'm going to go through it kind of quickly. There are some reserved IP addresses for certain things, so like research, etc. So the numbers that we have, particularly in the first octet, they're basically telling us what kind of IP address we're having and whether or not they're going to be reserved or not. So you may be familiar with this 127.0.0.1, which is your IP address to loop back on. And then, yeah, we've got some research addresses that follow through from that. NAT, do you remember about NAT? Yeah. So this means that you can, within your own private network, you can assign your own IP addresses and then sort of work through the interface out to the so that people on the outside of your network looking in from the internet, they will use a different IP address to access it, and so that gives you a larger number of IP addresses possible for you. And so I think this is probably, Pat is kind of like that. You're going to assign ports. If you look at the IP addresses here, we've got some additional information, port numbers that are assigned to each device there. So for example, they're all given the same IP address, but we add a port number to it so that, yeah, we're only using the IP address here on the gateway, and each one of these has its own port number. And so people looking on the outside, their IP address that they'll use to access this network is just going to be this gateway IP address. But then if they want to access specifically any device within that network, they're going to have to add a port address, which is going to be kept, recorded, and used in the gateway device. Gateway device is probably going to be a router. So static network address translation, dynamic network address translation, these kind of all work together in that thing. So it is network address translation. People in the internet are going to see those things slightly differently. So this person in the internet is looking at this IP address here, working through a dynamic network addressing. This address is going to be translated to this address on the inside of the network. The inside of the network, we got a private network, and we know that because of the IP address starting with 192. But on to the outside world, we've got these public usable IP addresses. So what's happening here? If this person here on the internet, I'm running out of time. This person here on the internet is going to use this IP address, but that IP address through the SNet, our static network addressing, is going to be able to refer to these 3 devices here, so that those 3 devices can communicate over the internet. And you'll see that they're all the same kind of devices. They're going to be our workstations. And yeah, I think that's enough for that. IP6, you remember this too, right? 16 bits in each block. It's a much bigger address. It is available on most network operating systems. but not necessarily always implemented. I'm not sure why people are sort of dragging their feet on that, but maybe it's because the stopgap ideas that we had, the NAT, has actually sort of been good enough for them. So there's just some information there about IP6 terminology. As I said, we're not kind of, when I last taught the 1101 course, we didn't really use IP6. We had the students doing subnetting with IP4. So tunneling, I don't know if you're familiar with that. Method used to transport packets through an IP4 network. So you can have a device which is using IP6 and you can have connectivity with IP4 by using that kind of protocols. Okay, so I don't know if you remember these things from 1101, unicast, multicast, and anycast addresses. The idea being that we can send a signal out on a network and we can specify many devices can pick up that signal, or few devices can pick up that signal using these ways of doing it, right? So unicast, if you just want to address a individual host on the network. These others, multicast, would be for specifics, but multiple. Anycast to everybody. Obviously, it's going to be more efficient if we use unicast or multicast than anycast. Anycast is going to, as deliver to any, but to the closest to this. You can see that here, I hope. Broadcasting is kind of like your anycast is kind of like broadcasting. Everybody gets the broadcast message. Multicast, particular devices get it. Unicast, a single device gets it. Anycasting is kind of like broadcasting, but depending on location. All right, there's some more. I don't know if this maybe is new. Is this part new that you didn't talk about? Yeah, all right. So about unicast and multicast, and we've got some specific prefixes. So if we look at our IP6 address, we have in the address, built into the address, whether or not it's a unicast, global unicast, etc., or a multicast address by the prefix that it has on the IP version 6 address. Okay. I'm sorry, I'm just reading these slides because I thought we were doing lesson 2, so my apologies on that. Yeah, so we create an IP address. Computer checks on that the address is unique. That should be. We have enough addresses with IP version 6, but but we are at level 3, and level 3 is internet, which is logical. So the device does not come with the address pre-configured. So that is a job for the IT person or the computer system that is built by the IT person. So they could be randomly generated IP addresses, or they could be addresses that are assigned by the network administrator, just like we did with IP version 4. And so therefore there is a possibility that an IP address could be used by another device. And so that there needs to be some checking on that. All right. So the router responds with DH. So once we've sort of generated an IP address for a device, the router is going to sort of check that with its through its DHCP protocol. And yeah, prefix discovery, generate its own link. Yeah. All right. So rather than sort of go through this like this, I'm not really enjoying this much. So I'm going to kind of stop talking on this, and because it's just, me reading slides, which I don't really like doing. So let's stop at that point. I'm going to stop the share. Let's stop at that slide. I will refer you back to that. We'll pick up that in the next lesson. We'll go And it seems that there is some new stuff there in this lesson, and we'll go through that in the next time. What I want you to do now is I want you to have a look at the exercise for the lab. The lab exercise is a packet tracer exercise. So could you just have a look at that? It is due on Thursday, but I'm giving you it a bit ahead of time because you're probably going to have to do some research on it, because it asks you to create devices with IP addresses, etc. And that's not sort of just intuitive. You're going to have to sort of look into that. How do we actually do that? So I'm going to ask you to have a look at that. On Thursday, I will go through it with you, but what I'd like you to do now is sort of have a look at it yourselves. Okay, so have a look at lab that's given to you. Maybe on Thursday, we might continue a little bit with this, this lesson as well. All right, folks. Sorry, I'm gonna stop it at that point. Is that okay? Any questions? Last in class. Okay. All right, students, I'm going to stop the lesson now. It's almost up to the 40 minutes thing. So, all right. Cheers. See you later, guys.
Have a good day, sir.
Please watch on here. If I find that quiz, I'll let you know. So please, I'll send you an email in a minute about the possible quiz. Cheers. Bye-bye.